Hey, Julian, how are you?
Yeah, good. And you?
Good, thanks. Okay, why don't we start off with you sharing your screen, and what you're going to do is you go ahead and just kind of say what you're doing so that you can explain how you're sharing it, and I think you're using your computer, right?
Yeah.
Okay, go ahead.
Okay. So there's a button at the bottom where you press share screen, and you can pick a variety of things. You can pick your iPhone. You could pick a camera. Right now, I'm gonna pick my Google Chrome, so you can see what I'm doing here. This is my Gulliver page, and this is our physics problem. So we can both see it at the same time, and we can both work on it as we're looking at the problem.
That's perfect. Okay, thank you. That's great. Okay, so let's go ahead and look at this problem. It says a basketball player starts from rest and sprints to a speed of 7.75 meters per second, and the time is 1.59 seconds. Okay, and we have uniform acceleration during the distance that he runs. Okay. Okay, so what I'm going to do is I'm going to go ahead and I'll I'll let you share. You're going to stop sharing, and then I'll share my screen.
Okay.
And now what I'm doing is I'm going to share my iPad, and I have to press the blue button that says share screen. And then when I go to my iPad, I do screen mirroring, and it will say Zoom MacBook Pro, and that's what I'm using. And so then you'll find that I have some software here that we can now use as a whiteboard. Okay. Okay. So in this case, what I'm going to have you do is you can write on a piece of paper, and you're going to show me what you do, but I'm going to write down a little demonstration of what I can write here, and you can actually talk to me while I'm writing. So actually, I'm just going to make a small person. That's my wonderful, beautiful person. And um, now, when we're using these equations, I'm going to just let you tell me what the variables are and what the equation is that we want to use for this.
So the variables are the time is 1.59 seconds, and the velocity is 7.75 meters per second.
Okay. Now, what are all the variables? So, like usually, like there are actually six variables when we're talking about kinematics problems, right?
Oh, okay. Okay.
Mm-hmm.
So there's the initial velocity, which is 0, the final velocity, which is 7.75, the time is 1.59 seconds, the position or the x in this case is you don't know.
Right. We do know.
And
We can say
then
that x initial is 0, right? And then x
yeah.
final is we don't know. Good.
And then the acceleration we do not know.
Good. And what are we looking for in this problem?
We are looking for the distance.
Okay, perfect. Okay. So now, what equation could we use to solve this problem?
We could use one of the kinematic equations.
Okay. And if you don't remember what they are, I will say which one just for brevity here, and later on we'll talk about that because there are three main ones that we use, but this one would be like x final equals x initial plus b initial t plus 1/2 at squared, right?
Yeah.
And the reason why I'd want to use that one is because we have v initial and v final. We only need v initial. Oh, actually, we do need v final because we don't have acceleration yet, right?
Mhm.
So we do need to find, so that's good to go through this. So we need to find the acceleration first to actually use this problem. Okay. So how do I find the acceleration?
You could use the third equation.
Yeah, v final equals v initial plus at. Okay. And the reason why I want to is because we have time. So that'll help us find what the acceleration is. So I'll just plug this in. We have 7.75 equals 0 plus a times 1.59. Okay? And if I can do this right, I would just quickly divide each side by 1.59. This is just to kind of go through the demonstration. And I get that the acceleration is about 4.87 meters per second squared, I believe. And now I can plug into here. So I can say that x final is equal to the initial displacement plus the initial velocity times the time, which will just be 0, plus 1/2 times 4.87 times 1.59 squared. Okay. And I can just say 4.87 times 1/2 times 1.59 squared. And then I get that x final is equal to about 6.16 meters. Okay. Okay. So now that's kind of okay. So now what I'm going to have you do is I'm going to stop sharing, and then I'm going to let you describe what you're doing, because you're going to first take a picture of what you just wrote down, and then you're going to share it. Okay.
Okay.
And that's kind of nice. It's the same process that I did with sharing my iPad, that you're going to be sharing your iPhone.
So it's basically the same thing. I'm going to press the share button screen, but this time I'm going to use iPhone via AirPlay.
Okay.
And then it'll give me the option on my phone to connect.
Very nice. Oh, you have such nice handwriting. So that's perfect. Okay. So that's kind of just a demonstration of how you can do a simple problem, and that's really great. So I think what we're going to do is we're going to go ahead, and I'm going to stop the recording now. Thank you so much, Julian. Talk to you soon.